What's up, everybody? Hope you're doing well. As mentioned, I was gonna post a video of a couple of problems that I didn't get a chance to go over yet, and so especially with 9.1.3 and 9.1.4. So I'm gonna be going over 9-31 with us real quickly. Um, it's really not as long. It's just a good principle to know, and please know this for future assessments. So this is what we call Cavalieri's principle. It would help to know how to spell his name, but if you explain well and just sort of botch the spelling, it's no big deal. Uh, but yeah, we are going to sort of use this with a thought of volume and surface area here. So Bonaventura Cavalieri was a mathematician who helped to develop calculus, but it's best remembered today for principal names for him. And we call this Cavalier's principle, and it can be thought of as a way of finding volumes in a relatively easy way. So let's say for part A, suppose you have a stack of 25 pennies piled one on top of the other. You decide to slant the stack by sliding some of the pennies over. Does the volume of the 25 pennies change even though they are no longer stacked on top of one another? So if we think about volume scientifically, right, it's basically how much space something is taking, right? Or how much space can you fill inside that one shape? So if we think about like a cylinder of like water, right? The volume of that cylinder is how much water or liquid or whatever that cylinder can take. In the same way, like each penny has a specific volume. It's how much space it's taking, right? And so if there's 25 pennies, that's 25 pennies worth of volume. So thinking about it, does it change if it's slanted, if it's pushed to the side a little bit? And with volume, it doesn't change. So no, volume stays the same. Okay, what about part B? Would that be true if a stack of 15 books, if you like twist it, like making a spiral? No. I mean, it is true. Yes, it stays the same. What about a stack of 1,000 sheets of paper? I mean, again, the volume of the paper doesn't change, right? So no matter how you move it or slant it, it will still stay the same. So for both of these, yes. So then for part C, the idea of viewing solids as slices that can be moved around without affecting the volume is called Cavalier's principle. So if you notice here, this cylinder is slanted at the right, and this is actually the same cylinder that we're working with here. So once again, the volume doesn't change. And so if we were to do volume for this question, it would still be the same way. Volume equals pi times the radius squared times the height, which is 25 pi times 8, which we ended up getting 200 in pi. So the volume is actually the same. Volume is the same as, what is this called? As a 9-30. So the big thing that I'm getting at here with Cavalier's principle is that the volume is going to stay the same. Now, however, that being said, while volume stays the same, think about surface area here with this cylinder. If you slant it, the surface area is actually going to change because this 8 is no longer the actual height of the cylinder, right? If we're talking about the length that covers from here to here, this is a different length. It's actually going to be bigger than 8. So your surface area actually changes with this cylinder in mind. So just letting you all know, with Cavalier's principle, volume stays the same no matter how you slant or turn the shape that you're working with, but your surface area can change. Okay, so that's 913. Okay, so we just finished 913. I realize we also need to talk about 912 real quick. And so with 9-16, this is a specific example that is a little different than previous block diagrams that we worked with. And here's why. So we'll go ahead and start with just volume and surface area for now. So part A, what is the volume of his tower and how can you tell without building the shape? So I already have the shape made in the e-tool that they use for this lesson, but I don't really even need it because if it's 6 identical layers of the shape below and top of each other, like this is huge, right? It's stacking 6 identical layers of the shape below on top of each other. So that means this shape is stacked 6 times. So first of all, if we notice, the first thing that we can do is just figure out, okay, how many blocks do we have here? So 1, 2, 3, 4, 5, 6, 7. So there's total 7 blocks per layer. If I have 6 identical layers, well, then all you need to do is just 7 times 6, which is 42 units cubed. That's the volume for this tower. Now, surface area is a different story. Okay. I'm going to go ahead and move over to the E tool here just to help us out. So this is what our current shape sort of looks like here. Let me see if I can. Okay. So with my E tool, I made this shape. So let's take a look at each view, because front, right, and top views times 2 helps us get the surface area. So the front view, we have a total of 3 rows, and then 6 columns, or sorry, 3 columns, 6 rows. So it's going to be 3 times 6. Actually, I need my web paint here. So for the front view, it's going to be 3 times 6, which is 18. But don't forget to multiply this by 2 to get the back as well. So that's going to be 36 for the front and back. Okay, moving on to the right side. Same thing. Right is also 3 times 6, which is 18. 18 times 2 is 36. And then lastly, the top view. The top view is 1, 2, 3, 4, 5, 6, 7. There's 7 blocks. So 7 times 2 is going to be 14. So in total, we would have 36 plus 36 plus 14. That's 72 plus 14, which is 86 units squared. Now, normally that would be the case. However, there is one small situation that's going on with this particular block diagram. Because if you notice, this little back section here, we have a little issue here. Now, if we notice, there's this whole section that's sort of like a empty little tower here. And with this in mind, and I'm trying to get the right view here. If I were to paint the right side of this shape, I'm actually missing out on this whole section right here. Because right now, I'm going to go back to the right view. This is all I see, right? But then when I go back here, I didn't take into consideration this back 6 blocks here. So that's an issue, but also, I'm going to try to swing it over here too. From the left side, you also can't paint this side as well. If you were to drop it in a bucket of paint, you have to also take into consideration these 6 blocks as well. So it's actually not 86. It's 86 plus 12, because these 6 blocks are not being shaded when you look at the right view and the left view. So hopefully that makes sense. So these six blocks here, these 6 blocks here are not being counted in this 86 total. So you have to add another 12 to make it 98 units squared. Okay, this is your actual surface area. Now, some of you guys might be thinking, okay, well, what about the back 6 right here, Mr. Chun? Well, here's the thing, right? If I look at the front, there's my 6. If I look at the back here, I'm trying to get it correct here. I know some of you guys are having a little roller coaster ride here. So looking at the back, this would also end up being shaded as well. So we actually don't have to worry about the front. The issue just came because the right and the left side, these 6 blocks, these 12 blocks are being impeded by the ones that are directly in front of them. Okay? So be careful with shapes like this, where they have this little crevice in the back here, or like somewhere else, and it might not be covered with just the front, the right, and the top views. Okay, so just be careful with that. There is another shape like that in problem 9-17, I believe, where if I reset it, it sort of looks like a cube, but the inside is hollow here. I think it's this shape in particular. So if I'm looking at this from the top, again, there is a block in the middle that it does not exist. So when you're doing your front and your right views, you're missing out on these three, these three, these three, and these three. So after you find the surface area of your shape here, you have to add another 12 blocks because they're not being covered by your front and right views. All you see is 9 and 9, but you're missing out on these 12 faces inside of this hollow cube. So hopefully this helps. Again, if you have any questions with these block diagrams, let me know. And we'll transition into our last lesson for the first half of chapter 9 tomorrow. Okay. Thank you.